To create threads for Lab 2 in Java, you can either extend the thread class or implement the runnable interface. And you need to have public void run method, but you shouldn't call run, instead you should call start. And you should not implement start, it's already there. And to wait for a thread to terminate, you use join. So if we have a class work, which does the work of a thread, then it can look like this, for instance. So it runs until this thread's list of nodes with excess preflow is empty. For the lab, this is an acceptable solution, but beware of that this list, I mean, if this list is private, then it may be empty for one thread and that thread says goodbye, but other threads still have active nodes. So there may be a work imbalance. How the threads, how the nodes should come to such a list, that's something that you have to solve and avoid data races, of course. But this is an example. Okay? I mean, of a run method. And a preflow function may look like this. So if you have the index to the start, to the source and the sync nodes and the number of threads, and declared an array of work, it should have work array with no dimension as the type for this variable. And then you create the array and create the threads. And then start the threads and then wait for the threads to terminate. So a Java program which is properly synchronized, well, not only Java program, but any program which is properly synchronized that avoids data races is said to be thread safe. One option to make a Java program thread safe is to use the built-in locks in each Java object. And there are two ways to use this lock. One is to declare a method synchronized, and then when the thread comes to this method, the Java virtual machine will check if the thread owns this lock due to having taken the object's lock earlier. And if it has not, I mean, if it doesn't own it, then it checks if the lock is already taken by another thread, and if it is, then the thread will not get it, obviously, and instead it's put into something called an entry set for this object. That's just a wait set for the lock. And then when the lock is released, due to the owning thread the thread which owns this lock has left all the synchronized method for this object, then some thread in this entry set is selected and is resumed and becomes the new lock owner. And of course, if no thread owned it, then this thread becomes the owner. This method to synchronize is applicable not only to methods but also to expressions. So you can have a synchronized block, and then you mention the object that should be synchronized with, and then you can I mean, when you have taken this lock, you can enter this block. But now suppose that another thread also well, okay, first of all, this is not sufficient, of course, to only take the lock for one of the nodes, but to make the example simpler, I just write one to demonstrate synchronized blocks. But suppose now that another node also wants to lock another thread also wants to lock these two nodes, but in the opposite direction. I mean opposite order. So the other one locks V and then U, and this thread locks U and then V. Then there is a deadlock, since they are waiting for each other indefinitely. To avoid deadlocks, it is a good idea to, well, one way is to use something called try-lock, and another is to set up a rule in which order that objects should be locked. I mean, locks should be locked. Okay, so we will look at both of these.